Hello, this is Steven, and I would like to give you a quick update on the work I've done the last 2 days to integrate LVGL in MicroBlocks. LVGL is a lightweight framework for creating and interacting with GUIs that runs on embedded systems, and is also available as an Arduino library. And then I thought, oh, MicroBlocks is written in Arduino, so why not port it to MicroBlocks. This LVGL has a lot of widgets you can use, and all the interaction that the user does is taken care of by the framework, so all the animation and things like that. And I thought that would be great, because otherwise you have to draw in MicroBlocks. You can of course draw with these TFT screens. You can draw your own GUI, but if you want to interact with it, the only thing you have is a touch screen, so you can maybe read out the positions, and you have to take care of whether a user presses within the same area as your button is, and all this kind of things. It's not really easy to do. So I thought maybe it's good to integrate LVGL with it. LVGL is quite a big library, so to get it running on this platform I had to cut down a little bit on other features. Eventually we have to see how we can squeeze that in, and the platform I'm running on is an ESP32W rover. That means it has PSRAM, although I didn't get it running for this graphical, but that's another thing. And the display is an ILI 9341 running on SPI, and the touch screen is the XPT 2046, also running on the same SPI bus. And of course you can draw this kind of things. I really like this, and the way I would like to integrate it is that I still could use these normal display functions, because I really like them, because you very easily can configure it, can put text on it, whatever you want. So I like that. So what I did is I made a library. It's LVGL, of course, and I implemented not all the widgets that you just saw here in this because there are really a lot of widgets. You have buttons, you have keyboards, everything. So I confined myself with only a few things. And what I first would like to show you is how you can toggle between the LVGL. It has its own canvas. So if I enable it, you see that it's becoming white. And if I draw something on it, for instance a button, I can say a button with a label. You see the button appearing at its default position, so I can change the position by setting the position. What I've done is all the widgets, all the objects are named. I just gave them a name, so you can choose button or whatever you want, and internally it's stored in a map where it maps this name to the real object. So using this name I always can refer to the object. So if I want to delete the object, I can take delete object, I take the name of the object, button, and I can delete the button. So this is really easy to do. If you want, for instance, a slider, that can also be done. Maybe want to position this slider somewhere in the middle of the screen. Maybe remove this button first and set the position of the slider. I can change colors. So I can say, okay, I want the slider green, for instance. Now you see that only the background is green and not the knob itself, so I can have an extra one. Now they should be both green. You can interact with it. All this interaction, MicroBlocks doesn't do anything with that. It's all being run in LVGL. And if I now want to know what the value is of the slider, I just can say get the value of this slider. And now you see it's 63. Now you see that it's changing. So this is the idea. So I have objects having a name, and I can put them anywhere I want. I can change them. I can, for instance, also change the size. So if I say the slider, I want a slider which is a little bit more, the width of the slider a little bit bigger, I can do it like this. Maybe I should do it like this. Now you see that it's okay. So this is all working great. One of the things I had to do is this LVGL works with a loop. So every time it ticks and it updates the screen, updates things, and this tick loop needs to be run in MicroBlocks within its internal loop. That's the VM loop. So I put the update of the LVGL in that loop, and the remainder of all the LVGL invocation is done in tft prims.cpp, and I made some if defs to put that there in. I can also see what kind of objects do I have now. I only have one, so if I add, for instance, the button, it's on the left corner, then you see that it has now two objects. And I can also change, for instance, I can put a label, so that's just like a text, small text box. I have to put that in the middle of the screen, for instance, or a little bit lower, like 200. Where's my, oh, it's it's within the, oh, it's, I should do it like this. Like this. I can even change the text. I can change the text of this label, so it's called label. That's the name of the object, and the text I can say, for instance, like this, and that works great. So I can delete all the objects. Now I will get an example that I written where I used a little bit more of these objects. So let me walk you through it. This is giving the LVGL. Oh yes, that's something I didn't show you. Maybe that's a good moment to show you. So if I put this, now it gets the LVGL screen, and if I turn it off, then I get the normal TFT screen. So if I for instance draw something on it, you see it will be drawn. If I toggle, it gives me the LVGL back. And the nice thing is, if I start this program, it draws some GUI elements. So here you see the arc, position, button. The label is not there yet. Okay, so we can use that maybe later on. And what I've done, and that's one of the important things, is that as soon as one of these, so you can, if you create, for instance, a button, you can say whether it generates an event or not. Some widgets, there's no need to have an event if you only want to display something. But if a button typically has an event, so it's enabled by default, and as soon as I hit a button, the event mechanism generates a broadcast, and I call it LVGL event, and I take that event in this loop, in this function here. So as soon as I press a button, for instance, you see that it gets broadcasted. It's got picked up by this function, and it will it can see the event. What it gets is the name of the object that I have an interaction with, and I limited the event only to clicked or to get value. For instance, like this, you see that the value is updated. And what you see here in the GUI happening is that these two sliders are like coupled, and that's done in this loop here. So I take the value of the slider, and I take the value of the arc, and I put the value in the slider to the same value, and I do for the arc I do the same. So they are coupled. Of course, it's just for the demo effect. So you see it's quite smooth. And this way you can make very easy GUI. And for instance, these buttons here, this row of buttons, I just have a loop to generate them. So I generate a name for the object. It's a button with a number concatenated, and then I just generate a button with the name of the object, and also the label in the button is the same as the object in this case, and I put them on multiples of 40 in the y direction. So this is basically it, and I can, if I want to draw things here, I can just switch back, and if I go back to LVGL, the whole thing is still present there. You see? What you do see is that the build-up of the screen is a little bit slow, and that's because in MicroBlocks, for graphics purposes, Arduino GFX is used. And Arduino GFX is a cross-platform graphical implementation, so I understand that that's being used, but the problem is that on ESP32 they don't use any DMA transfers, and that makes, even with SPI displays, make it very slow. So I can imagine that maybe porting it to what's called TFT SPI library, that would make sense to speed up things quite drastically. For instance, if I have the slider here, if I make it, if I change the dimensions of the slider, so let me put the size of the slider, and I make it very broad, like 300, and I make it like 50. I might have to change. Okay, if I now use this slider, you see that it's not really smooth. So now it has to update quite some graphics every time I change something, and it's not smooth anymore. And that has to do with this Arduino GFX library, which is not optimal for this platform. What I would like to do is I hooked it more or less inside this implementation that I've made specifically for this board. To have some more generic implementation will take some time, maybe also some effort from other people that like to join, but I think this is quite a good step in getting things running on MicroBlocks, and I'm quite happy with how it works and that it works. And yeah, so if you have any questions, you can find my posts in the Discord, and see you around. Bye bye.